going to go over a mix of different problems that I provided on a handout if you're using it. But it just gives you kind of a overflow of how to go through these problems. And these include the constant motion problems, they include the acceleration problems, they include acceleration due to gravity problems. So this is just a little kind of walk through what you should do in your brain as you're going through the problems. You're going to ask yourself if there's constant motion. If there's constant motion, there's going to only be one equation you'll use. Or if you're just given an overall distance and overall time, and they don't say it's constant motion, but you can't tell that there's any sort of acceleration based on the wording, you're going to go with this equation. But if not, there's going to be accelerated motion going on. You're going to have VIs or VFs. So you're not going to ever have Vs if you have acceleration going on. Even if they don't tell you what VI or VF is, you don't always need to use it because there's different equations where you can get around that. From that point, you need to ask yourself, okay, is it in the air? Is it under the influence of gravity? We call that free fall. And if it is, your A is going to be 10 meters per second squared down. If not, then you just have to still keep on going, asking yourself questions. And even if it is, you still would have to ask yourself these questions. Did it start from rest? Because you're going to know extra givens. VI equals 0 meters per second. Did it stop at the end? Maybe possibly it might tell you it was decelerating by 5 meters per second squared. That would mean that the value for A is negative. So you work through that. You figure out if it's accelerating in the air or not. Same sort of process. If it is accelerating, falling through the air, you still will have to think about, is it at rest? And from there, you pick your equation. And so based on that information, you're going to go to one of many of these equations. Remember, there's 5 variables you have in the accelerated motion equations. And if you have 3 knowns and 1 unknown, there's going to be one of these equations that you can go to. If it's the second part to a question, you might possibly have more than one choice, which if you did the math right, you would get the right answer both ways. Okay, so these are the equations we're going to be picking from if it's constant motion or accelerated motion. Let's just go through the practice problems. What's the final velocity of a bicycle starting at 2 meters per second, accelerating at 15 meters per second for 3 seconds? So what's the final velocity? There's your givens. Based on that information, once again, if you're having trouble on this, make sure you know your units. Make sure you know your variables that go with those units. That's going to help you pick out your variables. Don't forget your unknown, and that's going to lead you to one single equation. Of these equations, there's only one that has those variables in it, including the unknown. This is super important. The unknown, you can't pick your equation without it. And then you just plug in your values. You go ahead and do your math, check your calculations, and then we got, for this one with these numbers, was 6.5 meters per second. Now, if you're doing my one on E-class or on the computer, you're going to get different numbers that you're filling in. But it would be the same work, same process, so you can check your work and check for possible errors with my work. Okay. Initial velocity of a ball thrown down off a building that hit the ground 32 meters per second after 2 seconds. So in making your givens list, you need to realize the ball is thrown down off of a building. And what's the initial velocity of it? When it hits the ground, it's going to still be going down because it's thrown down and it's going to accelerate down. It's in the air, so you're going to have 10 meters per second squared. And it says after 2 seconds. So those givens, just how they gave you these, asking you for initial velocity, lead you to one single equation, which is going to be that equation there. And you just, from there, you're going to have to do maybe some rearranging, or you could plug in your values. Some people are going to do rearranging. What I did here to get to that is all I did was I went ahead and said, okay, I need to subtract VI from both these sides. And when I did, it got rid of that, and it made actually, I didn't do that. I went ahead and I was solving for VI, so I went ahead and subtracted. This is what I did. I subtracted AT from both sides, and when I did that got rid of the AT here, and it made VI equal to VF minus AT. So that's the math that I did when I did this problem, and then you just plug in your values from there. So just watch out for the signs and different things you have to do when you do the rearranging. And so I got 12 meters per second squared down for the numbers once again that I got here. So you can check your work, pause it, and just observe your work on your problems if they're unique to see if you made a mistake somewhere. Okay, what was the average velocity of a plane that took 3,600 seconds to travel 417,600 meters? Well, there's nothing in this problem that's talking about speeding up, slowing down. It's just saying velocity itself. So you're going to that equation right there. With these givens, only one equation you can use. You're not solving for the initial or final, you're just solving for the velocity overall, and then you just plug in your values, And you get 116 meters per second if you're using these numbers. Once again, you're going to have different numbers if you're taking my E-Class quiz. Okay, you are driving 12 meters per second when you hit the gas. Okay, so there's going to be acceleration going on. You're not in the air. You're driving on the street. What's your final velocity? You accelerated for 3.2 meters per second squared for 60 meters. So you started at 12. You asked for final velocity. Your acceleration's there, 3.2. Your displacement, you did that acceleration for 60 meters. That leads you with those givens to only one equation right there. Those four givens right here. Once again, just a reminder, there's only one equation that has those four givens, and that includes the unknown you're solving for. It's not always going to be up front. It might be somewhere else. You just have to rearrange. Well, here, I'm going to take the square root of both these sides. That's going to get rid of this, and then there's my value. There's my work from there. I'm going to plug in my numbers. When I plug in my numbers, make sure, this is important, you want to keep everything, I probably should have the extra parentheses, everything underneath the square root. You'll get 22.98 meters per second. If you're not getting this, or your answer correct with the E-Class version of this, then you might not have everything under the square root. Make sure everything's under the square root. How far is the ball falling? Okay, so it's in the air. Downwards from rest. It's at rest. That's another given. It's telling me. So it's falling, so that tells me acceleration. It's at rest, so that tells me it's VI 0. Traveling, by the time it's traveling 32 meters per second, and it's asking you for how far. So how far from rest till it gets to 32 meters per second, it's going to be going down. It's accelerating down. And just a reminder, if all signs are negative, if all signs are down, I'm just going to go ahead and use positive for down. So I'm just calling these both positive and my answer is positive, and it's a vector, then it's going to be also down, which is the case. The ball is going to fall downwards. So there's only one equation that goes with these variables. Once again, these four things are all found in this equation, just like a reminder from before. If you're having any trouble at this, you might have to go back to the accelerated motion lesson. Spent a little bit more time on it. Then you pick your variables. Now this is where the math gets a little funky, and that's why I wanted to take a second. So here, what I'm going to do is I'm going to subtract VI squared from both sides. And at that point in time, this is going to cancel out. So it would be VF squared minus VI squared equals 2AX. And now I want to divide out, because I'm solving for X. I'm going to divide out 2A from both sides. And then just a reminder, use a lot of parentheses, just in case you get lost in the order of operations. But that's how I get to this equation right down here. And from there, I just plug in my numbers. And if you plug them in correctly and you type it into the calculator right, for these numbers right here, you get 51.2 meters down. Okay, let's keep on going. How tall is a building? If a ball is dropped, so it's in the air again from rest, there's a VI equals 0. So very important, it takes 9 seconds to hit the ground. So there's your givens. Find the one equation that has all those givens, VI, X, A, and T. There's only one equation right there. Solving for X, so there's not too much rearranging going on. Plug in our values, and if you do the math right, when you plug these in, and you can even avoid that if it's 0 times anything, but you don't have to. You can type it in the calculator anyways. If you do it correctly, you're going to get 405 meters tall for these numbers that I had up here. Once again, watch out for rest, and it's dropped, so it's in the air. Now, the question itself, the ball is falling down, but the question itself says how tall is the building. So that's why this is how tall instead of downwards. The ball fell downwards, but we're asked about the building. So just to be particular on some questions. How long does it take you to travel from 200 meters if you constantly accelerate from 20 meters per second to 20 meters per for 2 meters per second to 20 meters per second? This is where you want to watch out your units. These are both velocities. These are not telling you an acceleration. So in picking your givens list, they ask you for how long. There's your T. They tell you 200 meters. They give you initial velocity of 2. They give you a final velocity of 20. These four variables lead you to one single equation. That's this one. Now with the rearranging of this, you're going to divide out VI, this whole ugly looking thing right here in the middle, divide by T. You're going to divide both sides by VI plus VF over 2. And that's going to cancel that out. That's going to cancel that out. And you're left with T equals X over this value right here. And then you're finally ready to plug in your value of your numbers. plug in your numbers, and if you did it correctly and have all the parentheses correctly, order of operations done right, you should get 18.2 seconds for something like this. So I have parentheses keeping all this down here together. I would have to actually even need more parentheses. Order operations just to keep the, we don't want the 20 divided by 2 before the 2 added to the 20. So here we'd want the 2 added to the 20 before we divide by 2. And then, so watch out, if you're typing in their numbers all the way, you might make this mistake. A lot of you might plug in numbers right off the bat and avoid some of these mistakes. But that's some place where order of operations could be important if you don't have those extra parentheses. How far have you traveled after going 5 meters per second for 8 seconds? There's nothing to tell you there's any sort of acceleration going on. You just went 5 meters per second for 8 seconds. You're not going faster, you're not going slower. It's not asking you where you started. So that's going to lead you to the v equals x over t. Constant motion equation, we're going to rearrange that. X is on top, we want to solve for that. So we're going to multiply t out, leaving you with x, and x equals v times t. And then we just plug in our values. We got 5 for v, and we got our 8 for t, and we get 40 meters. And this would be forward. It's not in the air, so it's not going to be down, and it doesn't give you a direction, so we're just going to say forward. So I'm going to leave that off. If it's ever forward, you won't have to give me the direction. What is the acceleration of a Ford Mustang GT that can go from 0 to 26.8 meters per second in 5 seconds? So what's acceleration? A question mark from rest or 0 to 26.8 meters per second. And the time takes us 5 seconds. There's only one equation with those variables, a, vi, vf, and t, a, vi, vf, and t. Plug in your, well, here we rearrange this. Now, this is where on your equation sheet you have another version of this where it might be useful if you have trouble with algebra to go straight to that. If we subtract vi from both sides, so minus vi from both sides, that gets rid of this vi. And we get, I'm just going to do the work down here because I don't think something shows up later down here. Vf minus vi equals at. And then we want to go ahead and we want to get rid of t. We're going to divide t by both sides. And that's going to get us to this equation. And so then we plug in all our values. And after we plug in all our values, when you do the math, you should get 5.36 meters per second squared. If it's on E-class, it's going to be meters per second per second. Just remember the way I type it in the E-class. It's just the easiest way to do it. So make sure you follow the instructions that are given on the questions on how to type those in. Okay, how far has a ball traveled after 3 seconds when thrown downward at a velocity of 3.6? So it's asking you for how far after 3 seconds. It's accelerating because it's in the air at 10 meters per second squared down. Doesn't matter what you did in the first place. This is still going to be, it's in the air. This is going to add to it in the downward direction. And it started down. So since these both are down, I'm going to go ahead and use the downward. I'll just say the downward direction is positive because I don't have any conflicting directions. Plug in my values. Once I do that, no extra math. It's kind of straightforward. Plug in all your values. In this case, we have a t. It's not starting from, or it has an initial velocity, and it's going to be downwards, and this is downward too. So you could either do one of two things. If you call downwards negative, you'd have negative 3.6, and you'd have to have a negative 10, and you'd get a negative final answer, and that would mean down. But we didn't do that. We went ahead and used positive values, and we got a positive answer. So that positive answer meant down. So since we used positive values for down, when we got to the end, we were left with positive. Once again, if you don't have to think about through this as much, if you have non-conflicting directions. Okay, what is the object acceleration that takes 500 meters to go from 5 meters per second to 8 meters per second? So they ask you about acceleration. They give you meters of displacement. They say you started at 5 meters per second and you ended at 80 meters per second. So there's only one equation that goes with these variables, these 4 variables, which is this right here. The object doesn't say anything about the object being in the air, so it's not going to be 10 meters per second squared. And then we're just going to have to rearrange. We're solving for a. So this one started like a rearranging earlier. We want to get a alone, so we need to get rid of all the other parts. So we go ahead and subtract minus vi squared from both sides, and that gets you to vf squared minus vi squared equals 2ax, and then we want to divide 2x from both sides. And so when I divide 2x from both sides, so that's what leads you to this equation right here. So I gave myself a little space to write in what you actually did. But a lot of you like to write in numbers and avoid some of the algebra by just plugging in numbers and doing the math that you can. So that's fine with me. You can do that and ask me questions if you're still having trouble with the algebra. But it's always good to practice your algebra. So once you plug in all the variables, if you do everything right, you have all your parentheses to keep the order operations together, you're going to get, for this question, you get 6.375 meters per second. Okay, how far have you moved while constantly accelerating from a velocity of 2 meters per second to 15 meters per second in 10 seconds? So how far have you moved? What's your displacement? Starting from 2.0, ending at 20 meters per second, and you're given 10 seconds. There's only one equation that goes with. Then you plug in your values. And for this answer with these numbers, it would be 110 meters as your answer. 110 meters forward would be a better answer, but if I don't tell you the direction, that's fine if you leave it like this. Okay, last question. What is the acceleration of a car that travels a constant velocity of 3 meters per second for 5 seconds? And this is where does constant velocity tell you about acceleration? It means no acceleration every single time. So watch out if they ask you for acceleration equals 0, but if they ask you for something else, you might be able to solve for it. So just watch out.